In this video, we're going to look at question 12 from the Learning Outcome 1 tutorial on the My City page for Engineering Dynamics. So here we're given a question stated in words where we have three vectors in play. And to understand what's going on here, we're going to draw them in a diagram like you might be given in some of the other questions. So we'll draw a line representing the horizontal. In this case, because we're working with compass directions, this line is the line along which we're going to represent east and west on our diagram. And then we're going to draw another line vertically that's going to represent north and south. So we just turn our ruler like so. And this is our compass point. So I'm going to mark these as north, south, west, and east. And we're going to write on some of the information we've been given in the question. And because it is compass points, we can identify northeast, southeast, and so on pretty readily. So what we're told first of all is the boat's travelling east at a speed of 5 knots in the river. So what we'll do is we'll draw on our diagram. I'll just do these very roughly rather than measure them out because we'll be saving that for when we do the graphical method. So we've got a vector pointing east, that's along the horizontal line. I'll just draw this in by hand, but I'll mark it in red. Going east and a value of 5 knots. We're told, as well as the fact the boat is travelling at 5 knots, so that's the speed it's been propelled forward at, the current is moving at 2 knots in a southwesterly direction. So southwesterly means pointing towards the southwest. So that's the direction it would be pulling the boat. So we've got a vector here with a value of 2 knots. And then we're told that the wind blows in from the northwest. So if it's coming from the northwest direction, it means it's blowing in a southeasterly direction. So we have a third vector here in the southeasterly direction, and that's a value of 3 knots for that one. So that's what's going on with this boat here, as 3 vectors applied to it. And the angles, although they're not stated in the question, the angles are actually going to be quite clear because southeast is halfway between south and east, and that's a 90-degree angle between south and east. So this will be a 45-degree angle here and a 45-degree angle here if we're heading, in that case, southwest. So we have all of our vectors and we have their magnitude and the direction. So what we'll do is we'll create a graphical vector diagram to resolve this and to find out the overall resultant vector. So as always, we're going to establish a scale for our vector here. Now, looking along the ruler, I don't see any problem with using one of these divisions between the big lines and the ruler to represent 1 knot. So a length like this here, I'm going to call this 1 knot. So if I've got a 5 knot length, which I'm about to draw in, I'll be drawing 5 of those. So we'll start off here. And to be nice and consistent with the colours I've used on the diagram, I'll use the same pen colours here as well so we can see what's going on. So 5 knots heading east. I'm choosing that one, but we could pick any of those 3 vectors to begin with. So I'll draw a line that's the length of 5 along here. So 1, 2, 3, 4, 5. Not the nicest line in the world, but there we go, 5 knots. That's our vector heading east. Now, to do the graphical method, what we're doing is we're going to add on another one of the vectors from the end, so the right-hand side of this vector direction it's pointing. And I'm choosing to do the blue one next, to do the vector that's pointing 2 knots in the southwesterly direction. That's the vector that's due to the current of the river. So what you do with your compass, I'm doing with my ruler just now. You can check out my other video where I do everything with the compass as well. Starting point at the end of the vector, I'm going to take my blue pen here, and I'm going to do a line that is 2 units long. So there'll be 2 of these units on the ruler. So I'll start my line here, and that's 1, 2. 2 knots means 2 lengths of the unit we've selected to be equal to 1 knot. And I'll do a wee arrowhead in this just to show the direction we're travelling in as well. And then perhaps unsurprisingly, I'll pick the third vector and final vector, and that's got to be at an angle of 45 degrees. Now remember, in my other video I might have done a wee dotted line horizontally to measure. Fortunately, with the whiteboard ruler, I can automatically set my angle to 45 degrees in the down to the right direction, if you like, or what's on a compass is southeast. So if we just get this set to 45. And we know we need a length of 3 units because each of our sections here is going to be equal to 1 knot. I'll select my green pen just to show you that vector being added on, and we'll draw it in like this. 1, 2, 3. And that's our 3 vectors from the question. So I'll take the ruler away for a second while I draw this in. Now, to find out the resultant vector, we want to go, I'll just highlight with my pen just now, we want to go back to the start here and draw a line that joins up with the end of the green vector here. And the length of that vector will be the magnitude of a resultant vector. And we'll measure an angle from either the horizontal or the vertical, so we've got a reference to say what the direction of that vector is as well. So first things first, let's draw our line. Now, if you're doing this on paper, you would just draw your line first and then measure the angle. Because I'm doing this on the computer, when I get the ruler lined up in a position where I can draw my line, it's actually going to be also telling me the angle that it's at. But I'll try and say things in the way we would be doing them if we were doing them on paper. So I think it's going to be between 31 and 32. We'll say 31 with this. Now you'll notice some of the answers in the tutorials have got decimal answers, and that's because they've been done by calculation. I don't expect you to give answers to more than the nearest degree in terms of accuracy. And I'll draw my line in here, so it's close enough to this here and to that point, and that's the end of the vector to the end of the vector. Before I move my ruler away, I'll try and take a bit of a measurement of this as well. So I'll line it up so I've got the start of a division at the start of this vector. So if I count up on the ruler, I'm counting up here. I've got 1, 2, 3, 4, 5, 6 full sections, and 1, 2, 3, 4, 5 and a bit out of 8. So 5 and a bit out of 8. So what's that? Well, 5/8 are 0.625 or something like that. So we'll say roughly about 6.6. That's what we're getting here. Now, you can obviously use a more precise scale when you're doing this with your ruler. So what I'm going to say here, and I'll draw my little arrowhead to show my resultant vector, I'm saying that I have an angle of 31, and that's, I'll be specific, that's south of east. So that's 31, so somewhere around it is 31 degrees south of east. That means from the east line we've gone down 31 degrees towards the south of east, and we're saying 6.6 knots with the length of that vector. 6.6 is what we worked out there, 6.6 knots. So that's an example on the whiteboard of doing the graphical method, and actually that compares pretty well to the answer that's given in the tutorial. But remember, those answers have been done by calculation, not by drawing. So your answers, if they're slightly off the ones given in the tutorial, don't worry, as long as they're approximately right, because even the thickness of the lines and how sharp your pencil is can determine accuracy here. So that's another example of the graphical method for calculating the resultant vector.